But I kind of thought I'd just bounce to significant recharge areas. So, and the use of models. So this concept of significant recharge areas has changed over the last 2 years in terms of source water protection. When the guidance modules first came out, there was a direction to take a look at trying to identify your areas that have the most recharge, and once you did that, then you would do a second step and try to see if you could trace the linkage between those areas and your drinking water supply, or at the time also to cold water discharge portions of your stream. So there was a connection that you had to make between identifying a recharge area and saying why it's significant. And that, I think, in the most recent work has been taken out. And now really the significant recharge areas are equivalent to your kind of high volume recharge areas. So if you have an area that's coarse sand and gravel with lots of water moving to the subsurface, that is enough to identify it as a significant recharge area. But one of the things that, so in terms of chasing some of this stuff, I mean, I'll just show you some of the things that can be done once you have groundwater flow models completed, and that's why I showed you the previous slide, just so you know there's a lot of stuff in them. But this is just an example of Duffins Creek, and they've looked at different pieces of their creek and looked at, you know, the darker areas have a higher flow in that reach than the lighter areas. And the next slide. So what you can do with a groundwater flow model is take those pieces where you've measured really high groundwater, you know, you measure it upstream and downstream, and you know that over that reach your flow has increased tremendously. Or you know from your fisheries staff that you've got spawning grounds for brook trout, so on. But you can start, once you have a groundwater flow model set up, you can start to take any of those reaches of streams, and what we've done in this case is indeed we've done that, and put some particles into the groundwater flow model, and the particles go backwards through the flow system and trace out the route that they took to get to the stream. And so I think in this case we've sent them back 5 years in time, and then if you go to the next slide, you send them back even further, you get this big hairy map that's, kind of, what the heck to do with this. But at the end of the day, the next slide, what you can do is start to take a look at where those particles come to the water table, and then take a look at how long it's taken for the water to move from the point it's hit the water table to discharge in the stream. And so, as you would expect, this is taking all those individual tracks and putting a time dot where it's come up, and then you can contour those all together and get kind of a map of the travel times that the water's taking to get to the streams. Now what this tells you is on the moraine itself, the water is moving down and then through the flow system, so it takes an awful long time. Closer to the streams, any water that's recharging into the groundwater system is much shorter to get to the streams. So it's just it's a way of teasing out the travel times to your streams, not necessarily giving you your significant recharge areas. I mean, these are, the Oak Ridges and Moraines obviously are very significant recharge areas, but maybe these areas adjacent to the stream are also significant. I mean, they're moving very quickly. So there's a bunch of things that, again, we're going to try and tease out of some of this work. And just another similar example where you had some discharge, again, at the lower end of the system, and the particle tracks go in the deeper aquifer systems all the way up to the top of the moraine. The next slide shows the same thing in cross-section. So here's where you're getting your cold water discharge, and you can see that some of the recharge actually comes through the till plane here. Most of it comes down from the Oak Ridges and Moraine, but would you consider this area a significant recharge area or not? These are kind of all the questions that really are swirling around identifying significant recharge areas. In this case, it's tied. Now that we've moved to just looking at municipal drinking water, these kind of issues with respect to streams aren't really part of source water, but they're still part of water management and broader watershed planning and so on, which of course conservation authorities are interested in. here's my drinking water couple slides, but the same sort of thing when you move to municipal wells, you do this same sort of thing. I don't know how familiar you guys have seen any of this stuff or not, but you put wells in, the wells are in the subsurface, and again, you do the same sort of thing to have your particles travel backwards through the groundwater flow system and chase out the pathways that water is taking in the subsurface. So there's all sorts of things. Once you have a groundwater model that you're confident in, then you can do a lot to try and understand the system. And this is just a plan view, the same thing, looking at municipal wells and particle tracks out from the wells. Next slide. At the end of the day, you just put them all together, and you've probably all seen this in your committees. And at the end of the day, with source water, my only source water map, and this is from Rick as well. But here's all the communities in the GTA that still rely on groundwater and the capture zones that have been delineated. Again, I had just another one of these messy particle tracking slides. So then in terms of delineating, I thought I'd just quickly go through one of these exercises of delineating significant groundwater recharge areas. And if I'm way over time, then
you're fine.
Everything cool?
I'll let you know if...
Okay, yeah, because if you, I can shut down anytime. I'll just ramble to you. Throw me out. So there's two methodologies, 55, you can look at one where you say you want to look at areas where you have 55% of your water surplus. Anything greater than that is going to be identified as a significant groundwater recharge area. Or where you've got kind of more homogeneous superficial soils, you could take a look at trying to tease out areas that might have slightly higher recharge by looking at 1.15 times the average recharge rate in your watershed or sub-watershed. And again, scale comes into play here. How big of an area do you look at when you're looking at these kind of numbers? Anyway, so we were asked by the Trent group to take a look at helping them delineate their significant recharge areas. And so I just quickly go through a bunch of slides that aren't really all that exciting, but you have to look at your precipitation data and how it varies across the area. So you got more precipitation in the north, less in the south. Got to put that into your head. Next slide. Same with temperature distribution. So colder in the north, warmer in the south. You got to think about, are you going to take the whole watershed as one climate zone? Do you divide it up based on watersheds, on physiography, on whatever? What we ended up doing is taking 3 representative climate stations, Cobourg, Peterborough, Minden, to represent a north, central, and a south area. And so those were going to be for the purpose of delineating these significant groundwater recharge areas. We split into 3 areas. Next slide. You take a look at your superficial geology. In this case, we had a big blank hole that actually is one of the, I think it's the only area in southern Ontario that the OGS had never mapped. So we took a look at the agricultural soils and tried to map the agricultural soils over to the superficial quaternary geology soils. Next slide. You have to, with the Thornthwaite and Mather, this was just a really simple approach. With that early, the first methodology I showed you, we went back to that. So we had to get some soil moisture capacity numbers to put into the equations, and this is just showing the distribution based on our superficial soils, on the agricultural soils actually. And so in the north we struggled a bit because there's no data up there. And you assign some recharge rates to your soil types, and this is largely based on groundwater modeling in the south that we carried into the north. And you do your analysis on your Thornthwaite, your precip, your temperature. You wind up with your water budget surplus. You take your numbers based on the 55% of the surplus, and what you find out is all these yellow soil types are the ones that come out as being significant groundwater recharge areas. So really it's just a roundabout method of mapping your superficial soils in the end.